and that will cover space conditioning requirements. When it comes to space conditioning, most equipment installed in new homes are regulated by the National Appliance Efficiency Conservation Act, which is NAECA standards, or the California Appliance Efficiency Regulation, also referred to as the AER. The standards are applicable to equipment used in replacements, repairs, or for any other purpose. So equipment not meeting NAECA standards cannot be sold in California. The AER and NAECA are enforced at the point of sale, while the energy efficiency standards are enforced by the local enforcement agencies. And keep in mind that the AER does not require certification for infrared heaters, electric resistance heaters, oil fire furnaces, or room heaters.
So let's now take a look at the mandatory measures for heating equipment. We'll look at cooling equipment here a little bit later. First, we're going to go through all the heating equipment. So there are minimum efficiencies required for central gas furnaces. Those will be outlined in Table 4-1 of Chapter 4 of the Residential Manual. Now, Chapter 4 is the HVAC chapter for the Res Manual. We're going to reference many different tables as we go through. So anytime you need a value, because we're only going to list some of the more common ones that you'd find in residential construction, but there are many others, go to this table and it will have the full list of all those items. So for a central gas furnace, we're looking at an 81% AFUE, or annual fuel utilization efficiency. This would be for weatherized furnaces under 225,000 BTUs per hour, and an 80% AFU for non-weatherized furnaces under 225,000. Any minimum efficiencies for non-central gas furnaces and space heaters will be outlined in Table 4-2, and they do range between 57 and 76%. Minimum efficiencies for heat pumps will be outlined in Table 4-3, and for a single phase air source less than 65,000 cooling, an 8.0 HSPF package unit and 8.2 HSPF for split units. Minimum efficiencies for central boilers will be outlined in Table 4-4, and for a gas hot water boiler, we need to have an 82% AFUE. And then our heating loads for the home do need to be calculated for new heating systems, and these may be done by either a mechanical engineer, the mechanical contractor who is installing the equipment, or someone who is qualified in the state to do so. Gas-fired heating equipment may not have a continuously burning pilot light. For larger furnaces that have input ratings equal to or greater than 225,000 BTUs per hour, must also have an intermittent ignition device and either power venting or a flue damper. Heating system piping for heat pumps and hydronic or steam systems must meet the requirements of Table 4-5 in Chapter 4 of the Residential Manual.
They must be controlled by a setback thermostat or integrated into a central energy management control system, or EMCS. And this is only applicable to central heaters, including heat pumps. Any heat pump with supplementary electric resistance heating must have controls that have two capabilities to limit the electric resistance heating. So if you've ever seen a heat pump, you'll see a switch that most of the time it'll say heat and then emergency heat. Most of the time the emergency heat turns on electric coils to provide additional heat to the house. So that is not allowed by Title 24. If they do have it, they have to have basically a switch that limits the use of that electric resistance heating. As far as prescriptive requirements are concerned, all they can install is gas heating systems or heat pumps, and then supplemental heating can be installed in areas serviced by a main heater as long as they meet certain efficiency values and are controlled by a time limiting device not exceeding 30 minutes. So if you think of a auxiliary heating system for maybe a bathroom or a walk-in closet or a changing room or something along those lines, they can install those type of systems as long as they meet that particular criteria. Now, performance-wise, they can install an electric resistance heating. As you can see in the prescriptive requirements, it says that gas heating systems or heat pumps must be installed. So performance-wise, the Title 24 analyst may choose to install an electric system if they can show that the electric system meets or exceeds the energy efficiency of a gas system. And that has to be done through the performance compliance option. There is no other way. And then there's additional credits that exist for high efficiency equipment. So they can take additional credit with the Title 24 software if they want to install high efficiency heating equipment.
All right, so that takes care of the heating equipment. Now let's look at the cooling equipment. So we have the same type of minimum efficiencies for the mandatory measures that we did on the heating side. The same are regulated by the NACA or AER standards. We have a 14 SEER minimum for central AC that is less than 65,000 BTUs per hour. And then values for other types of equipment can be found again on tables 4-6 and 4-7 in Chapter 4 of that residential manual. In addition to those minimum SEER values for central AC, we also have some minimum EER values. We have 12.2 for a split system with a rated cooling capacity less than 45,000 BTUs per hour, 11.7 EER for split systems rated cooling capacity more than 45,000, and 11 EER for single package systems. And just like with the heating loads, cooling loads must also be calculated for new cooling systems, and these may be done by the mechanical engineer, the mechanical contractor who's installing the equipment, or someone who's qualified in the state to do so. So the same three allowances for people to do those loads.
In addition to that, a hole for the placement of a static pressure probe or permanently installed static pressure probe shall be installed downstream from the evaporator coil. Now, some of these holes are going to be required for certain HERS tests that have to be completed as a mandatory measure. So because of those tests, this becomes mandatory as well. The section line of the refrigeration lines has to be insulated to the specifications of Table 4-9 of the residential manual. The liquid line does not, but the section line does. This is nothing new that has been done for years. Nonetheless, it has to be completed as a mandatory measure on cooling equipment.
Condensing units shall not be placed within 5 feet of a dryer vent, and this is to prevent buildup of lint on the condensing coil. The condensing coil needs to have air move freely across it to remove heat from the refrigerant, and it can't do that if it is blocked and plugged with layers of dryer lint. And then if required by the manufacturer's instructions, liquid line filter dryer must be installed. On the prescriptive side for our cooling equipment, we have just one item, and that is refrigerant charge. So that is going to be required in climate zones 2 and 8 through 15. You could install a fault indicator display in place of performing that refrigerant charge verification. We do talk about that more, what it is, in the refrigerant charge section. If refrigerant charge is required, then there is a requirement for the installation of a measurement access hole. This will be drilled and placed in the return plenum, and this is to verify air temperatures that are flowing across the evaporative coil.
For performance compliance options, you have the option of installing high efficiency air conditioners, and this will be modeled in the CF1R. You have the option of performing an air handler, fan water draw, and cooling coil airflow. Now, these two particular items can also be a mandatory measures at a minimum level, but from a performance standpoint, you can choose to model these tests at a higher efficiency level to get credit for them. So there is a base mandatory minimum for these tests, but then they could be modeled using the performance option to go above and beyond what the minimum requirements are.
Now we'll move on to the air distribution system ducts and plenums. So again, our mandatory measures, we have a minimum insulation requirement of R6, and this does include ducts that are located in a concrete slab. There are minimum standards for materials that are used to build and seal a duct system, and these duct installations must comply with the California Mechanical Code, Section 601 through 605, and the Building Energy Efficiency Standards. Duct sealing is required in all climate zones. That is a HERS measure, but it is a mandatory measure, so it's going to be required in all climate zones.
In addition to that, we have to verify to make sure the air filtration system is in fact according to code. This is applicable to a heating or cooling system with more than 10 feet of ducts, not including evap coolers. So this requirements has to do with the system design criteria. Basically, is the return system designed and installed properly? The air filter media efficiency criteria, so is the correct filter MERV 6 or better being installed in the system like it should? Air filter media pressure drop criteria. There is pressure drop values associated with each type of filter, and each filter is supposed to be matched to the system that's being installed in. So those values have to match the system that's associated with. And then air filter media labeling criteria. So there has to be a label explaining the values that we just talked about a second ago as far as the pressure drop and the airflow rate somewhere on the return, so that when somebody replaces the filter, they'll be able to replace it with a filter that matches or exceeds the standards. Now, for non-zone systems, except for heating only or non-ducted systems, the systems must comply with the fan watt draw and adequate airflow. Those are two HERS measures and tests that we'll cover in detail later in the training. So they have to comply with that, or they may install return ducts and grills in accordance with tables 4-10 and 4-11 in the Residential Compliance Manual, or 150.0-C and 150.0-D in the standards. So those are the same tables, they're just labeled differently in the different documents. So you can either do fan watt draw and adequate airflow, or you can increase the size of the return duct and grills according to the tables, which we'll see in a sec, in order to meet the standard. And this is table 4-10, so you'll see 4-11 in the next slide. But basically 4-10 is specific to single return duct systems. So if you have a system that only has a single return duct, and it's only up to 2.5 tons, as you can see on the left-hand side, system total nominal cooling capacity, you'll be able to use this particular option by increasing the size of the ducts to those sizes for both the ducts and the return filter grill gross areas. Now, if you have multiple return duct systems, then this table goes all the way up to 5 tons, and it works the exact same way as the other table. You will simply just increase the return duct sizes and the return grill areas, and you'll be able to get away from doing the fan watt draw and the cooling cool airflow. Now, in addition to increasing the return duct sizes and grills, there's additional things that you have to follow. So there is specific requirements for the return duct design and specifications. So the return has to be within 30 feet of the plenum. When bends are needed, metal bends are desirable. And then each return cannot have more than 180 degrees of bend, and no more than 90 degrees of bend can be flex duct. So this is also a requirement if you're trying to get away from doing the fan watt draw and adequate airflow.
Now, for those systems that are zonally controlled, central AC ducted systems, this means you'll have dampers within the system so that you can heat or cool zones of the home rather than the whole home being heated and cooled at the same time. We do not have that option to use tables 4-10 or 4-11. You must do fan watt draw and airflow testing and verification. So again, we need to provide 350 CFM per ton through the return grill and draw less than 0.58 watts per CFM. Now, how we go about doing this is going to be dependent on the type of compressor that's installed inside the condensing unit. If it is a single speed compressor, then you will need to test in every zonal control mode. If it is a multi or variable speed compressor, then you will test with all zones calling with the fan at maximum speed and the compressor at the maximum capacity. Now we'll go into the actual testing protocols for this in more detail when we get into the fan watt draw and airflow section or portion of this training. For the prescriptive requirements, we do have some minimums for duct insulation. These are going to be climate zone specific, so we're going to require prescriptive require R6 insulation for climate zones 3 and 5 through 7, and then R8 for climate zones 1, 2, 4, and 8 through 16. So there are several more climate zones that are requiring R8 for 2016 versus 2013.
And then you have performance compliance options. So again, the following are going to be options that building analysts are able to take to get additional credit toward Title 24 compliance. So the first one is supply duct location. You can choose to install ducts in conditioned space in order to get credit for them. You can have buried ducts or deeply buried ducts. So basically bury your ducts in insulation or additional insulation in order to get better credit and better efficiency out of them. Another option they have available is the diagnostic supply duct location, surface area, and R value. So basically the HERS rater would have to verify that the duct design is installed exactly how it is on the plans, from the duct locations to the duct sizes to the location of the return and supply registers, to the size of the equipment and everything in between. And then there's also an option for a zonal control credit that may be taken. Now this is a little hard to take. I mean, it's been around for a while, but you'll see in a second why it's hard to meet. So these are the 5 criteria that need to be met in order to take this credit. So it could consist of multiple systems or one system with zoning capabilities. While the credit only requires one living zone and one sleeping zone, you could have more than 2 zones. Each zone must be controlled by a central automatic dual setback thermostat. Each zone must be served by a return air registry located entirely within the zone. And the last requirement is the one requirement that's hard to meet, which is must have less than 40 square feet of non-closable openings between the zones. So non-closable openings means basically archways, openings that cannot be blocked in any way whatsoever. So if you think of maybe a 2-story home that has a loft with an open to below, that is a non-closable opening. It's completely open to below. It's most likely way beyond 40 square feet of area. So it would be very hard to meet that particular requirement. And that is the reason that most people do not take this compliance option.
And then we have the whole house fan. Now this is a prescriptive requirement, and a whole house fan is oftentimes confused with the mandatory whole house ventilation requirement. So this is not for ventilation, this is for cooling. So the way these work is that you open your windows to the outside, you turn this fan on, and when the temperature outside is cooler than the temperature inside, this fan will draw the cool outside air in through the windows into the home, exhausting the warm air from inside the house out into the attic, and then it uses the attic vents to let that air escape back to the outdoors. So it circulates cooler air into your house, cooling the inside. It is not for ventilation purposes. So it is prescriptively required in climate zones 8 through 14. There are equipment requirements, just like all of our other equipment, for minimum efficiencies for motors and all that type of stuff. The minimum attic net-free vent area to the outdoors is 1 square foot for every 750 CFM of rated airflow. The homeowners do need to be educated on how to use it. If they don't use it correctly, obviously they're not going to get the desired results. And the fan needs to be sized with a listed airflow of at least 1.5 CFM per square foot of house conditioned floor area.
And while this is only for informational purposes, there are additional alternative systems that you might see out there. This is an example of a hydronic heating system. It basically uses hot water to distribute heat. It consists of a heat source, which is either a boiler or water heater, and a distribution system, which is the piping. So there are 3 main types of hydronic distribution systems. Generally speaking, you'll see baseboard convectors or radiators. You have hot water air handlers, or you have radiant panel heating systems as well. So you can refer to Chapter 4 of the Residential Manual for additional requirements of these systems. Now, radiant floor systems, they can be hydronic or electrical. Obviously, if it's electrical, it has to be specified in the performance compliance options. It can just be taken automatically if it's electrical. The piping has to meet mandatory insulation measures, which we talked about in the past during the insulation section. So the slab has to be insulated if it's in the slab. If it's in the floor has to be insulated and layered properly as well. Here you see an evaporative cooling system. So it provides cooling to a building by either passing outdoor air through a wetted evaporative media, so basically like a wet sponge. You can see in the picture right there, you basically have hot air being pulled through a wet pad of some type, and it kind of moisturizes it that way. You can do indirect cooling through a non-porous heat exchanger, separating evap cool secondary air from outdoor air, or by combination of direct and indirect that combines an indirect heat exchanger with downstream direct evaporative process. So it could be a combination of all those three items. Now, as a heat pump, a fan pulls outside air over the coils. The liquid in the coils absorbs the heat in the air and expands out vapor. Then the refrigerant condenses back into a liquid as it cools and flows outside to pick up more heat. The heat, meanwhile, is pumped back into the air ducts of your home and distributed throughout the house. So that's how a heat pump works. So a ground source heat pump works similarly like a regular heat pump, but instead than taking heat out of the air, it's taking it out of the ground. But it's the same principle in nature. Well, you may run into solar space heating systems out in the field. Solar space heating systems are not recognized within the prescriptive packages or the performance compliance method. So they might be used as a backup of some type, but they're not part of Title 24 per se. Now, you might see wood space heating as an exception. The Energy's Commission method for wood heaters with any type of backup heating is available in areas where natural gas is not available, so it's literally just a backup system. If the required eligibility criteria are met, a building with one or more wood heaters may be shown to comply with the standards using either the prescriptive or performance approaches, but again, it's going to be on an exceptional basis. An evaporative cool condenser uses a water cooling system to aid the condenser in dissipating heat from the system. If installed, the HERS rater will be required to verify duct sealing, adequate airflow, and refrigerant charge, or the CID. So think of it as a regular condenser that has a sprinkler system built into it that helps cool down the refrigerant. An ice storage air conditioner basically uses the formation of ice to cool down air. So what it does is it creates ice during off-peak time, and then it shuts the refrigeration system down during peak loads and just uses a fan to blow hot air through the ice that it formed during off-peak time. So basically think of it as putting a bowl of ice in front of a fan, and then as you blow the fan in the direction of the ice, the air on the other side of the ice will be slightly cooler. It's the same principle. There haven't been any units installed in residential as of yet. It's mainly a commercial application, but they're supposed to be bringing them to residential application as well. And finally, non-duct and mini-split systems are basically systems that are divided into different components. So you'll have a condenser that's outside, just like any other condenser, obviously a little smaller, and they can be connected to multiple blowers, and those blowers are servicing individual areas of the house. It's non-ducted, so this doesn't apply to the cooling, cool airflow, and fan water draw requirement or duct sealing, obviously. They're fairly efficient. Each blower has its own thermostat and remote control to directly control the operation of that particular blower. You're not really going to see them in residential new construction. You're mainly going to see them in a retrofit type of application where maybe there is no room for ducts, or they're specifically installed in areas where additional cooling is needed in addition to the central system. Any requirements for the system that I just talked about that fell under alternative systems, you can find additional information in Chapter 4 of the Residential Manual for additional requirements for each of them. So let us know if you have any questions via the messaging system, or shoot us an email or give us a call. There was definitely a lot of information covered in this PowerPoint, and this is new material to you. I would be surprised if there was no questions. So feel free to reach out to us or save your questions for the field training, so you'll be able to ask the questions to your field trainer.